Hello, thank you all for being here at our first meeting for our review for our tests. I hope all of you are doing well. So let's get started. Alrighty. So for our for any Zoom meeting, I'm always on with two devices. I have my tablet and my laptop so that you can see me, we can talk. It's more like a meeting and not just like a pre-recorded video. And I have my tablet so I can walk you through the steps and do some problems. So we're gonna have our first exam, and that's what we're gonna review. Let me go ahead and share my screen. Along with the announcement with our link for our Zoom meeting, I also included a review. Now, since it's our first test, and I don't know if you feel scared about it or worried about it, this review is like almost verbatim what you'll see in your exam. So if you can do this exam review, or if you practice it so you know how to do it, then you will succeed, you will be fine. So there are some problems that I would like to do. I don't want to take up your whole time, and I generally do not like to make my meetings too long because I know at some point I feel like everyone just zones out and kind of ignores me. So I like to keep them within an hour. So there's only some problems I'll work out. So before we start, let me help you with Zoom. So I'm sure you had your Zoom meetings before. So the way you can ask questions, you're all muted. And the reason I have you all muted is so that you don't hear any background noise, like with someone writing or moving their laptop around or whatever. So you're all muted, but if you ever have a question, please unmute yourself and ask a question. If you're shy to ask questions, like me, I'm very shy to ask questions during Zoom meetings. You can always use chat. So the chat, if you move your mouse around the bottom of the Zoom screen, you'll see either a chat little icon, or if your screen's too small, you'll see an ellipsis, and that's where your chat box in. So I just posted in the chat, hi everyone. And when I mentioned about the test, someone was like, I am the scared. Okay, hi scared. I'm always scared about everything. When I said about Zoom meetings, and I'm in Zoom meetings and I have to like talk, I'm always like, oh my God, what I'm gonna say, I'm gonna sound bad. And so I understand, but if you have a question, please voice it, because if you have a question, someone else has the exact same question. All right, let's go ahead and begin. So your test is made up of 17 questions. They're all multiple choice. You're allowed 3 hours. You do not need 3 hours to take the test. Maybe an hour or so, but I give you a lot of time just in case, I don't know, something happens. I know you're at home, we have some distraction. So that's just to cover all the bases. You're given 2 attempts, and you have a week to complete it. I always give you a week to complete all your assignments because I do not know what your day-to-day looks like. I also don't know what your workload is, or if you have something else to do around the same time for a class. That way you can kind of see and move around your schedule, see what you're going to do first, what you're going to do last, and so on. And it's due October 1st at 11:59. So make sure you're done with it by 11:59. It shuts off at that time. All right, so I see some questions. Someone said that they said that some of the concepts are kind of confusing and it's kind of hard to remember it all. I totally agree. I think at some point, all these things kind of just mush together, but that's why we practice them, and that's why I give you a review, so you kind of have a quick refresher of what you'll see in the exam. I see in the chat someone said, are you going to be going over the review test? Yeah, I'm going to be going over some of the problems. You also have a key, so you have every single problem worked out as well. You can always refer back to it. Is an open note test? Yeah. Have your notes out, have your book handy, have all your resources around you. I will not say, hey, it's not an open note test, because I can't really monitor what you're doing. Even if I did use some kind of proctoring applet on Canvas, you can still go around it, right? So have your notes handy. Make sure you're learning and you're understanding. So yeah, open note. Will there be an answer key for the review test to check our answers? Yes, it's on the page where I posted all the Zoom information. There you have this review, both as a Word and a PDF. I always give you everything as a Word and PDF just to give you options to view your documents. And the key is as the PDF because I scanned it. There you see all the work and all the answers. And for some problems, I give you like a little note as to why that happens. But if you have any other questions as you're studying, email me. I am sadly always by my computer. So email me. I think I'm trying to work out a new schedule where I go to sleep early, wake up early. So if I don't get to you when you send it at night, I will for sure see it and answer in the morning. Okay? All right, let's go ahead and get started. So I'm going to do the problems that have little star and asterisks on them. The first one we see with that is number 2. State the domain and range of the function. All right, so domain, that one's not so bad. We know that for domain, we want to see what can x be. There's some restrictions depending on our function. This one, because we have a rational function, we do not want a denominator to be 0. So let's go ahead and start denominator equal to 0, and that is our what's not in our domain. So we have that x minus 4. So we're going to set x minus 4 equal to 0. We solve for x, so we add 4 to both sides. And I get x equals 4. So our domain is all numbers except 4. But that's not how you'll see it. Your exam will want it in interval notation. So all numbers except 4 would mean from negative infinity to 4. Infinities always have parentheses. This 4 is not included, so it has a parenthesis. We have a break, and we continue from 4 to positive infinity. So that is our answer for our domain. Now, what is our range? To find where that domain value translates to our range, we just plug it in, but it's a denominator that would give us a 0. So for this one, luckily it factors. So I always do my little factoring x. I know it's beyond you, but I always do it. So what numbers multiply to give us 20 and add to give us -9, -5, and -4? So this factors to be x minus 5, x minus 4. And that x minus 4 expression divides to make 1. So we're left with x minus 5. We plug in that 4 from our domain. So we have 4 minus 5, we get -1. So for our range, it's every number, and that corresponding domain to our range is -1. So it's every number except -1. So our range would be from negative infinity to -1, -1 to infinity. Someone asked if you can take screenshots. Go right ahead. Take a screenshot. Remember, you also have a key with all the same work there. So I don't know if you want to do that. Whatever you'd like. Feel free. That was number 2. Number 4. So
I have a quick question.
yeah.
So, okay. So when you're finding the range, did you plug the 4 in from the domain?
Yeah.
Oh, okay.
I thought the range was all possible values of x. So is -1 not a possible value to have?
So your range is your outcome, right? So our domain is all numbers except 4. So I need to find that corresponding range value from our domain, because our domain translates to our range.
Yeah, that makes sense. Thank you.
Okay. I'm like, how can I word it? I know. Domain and range You know what's sad? I don't think I truly understood the concept until like I was teaching it, and that never goes away. So imagine my struggle. All right, so these problems from chapter one. Chapter one had those like algebra reviews and those trigonometry stuff, those basic stuff. So for this one, you see, I don't know where your trigonometry background is. If you ever have questions, ask me. I teach all the time. I think it's one of the funnest ones. So if you have any questions or you're not sure how something works in the unit circle, let me know and I'll be happy to help you out. So one of the ones I'll do is that evaluate sine of negative 2 pi over 3. So for this one, have your unit circle handy. You can always Google search a unit circle. I think in my math lab, there is a button that says unit circle and it refers you to the unit circle. And I also just added today a unit circle cheat sheet and an identity cheat sheet to that top module where we have our schedule and my office hours link. So I added another page to it that says unit circle and identities. All right. So for this, I'll do number 4. It's asking to evaluate sine at negative 2 pi over 3. So when I have negative, it's just a direction. So I'm going towards the negative, so I'll be going clockwise. So if I go one quadrant is pi over 2, another quadrant is pi, another quadrant is 2 pi over 3. So I'm at negative 2 pi over 3. What is this point? For my unit circle, it's the point 0, 1. Now, every point along the unit circle is always given as your cosine value and your sine. So sine at 2 pi over 3 is 1. Okay, next question on our list is number 8. So these problems are like what you're gonna see, but you'll see, of course, different numbers, different pictures, slightly different, right? Number 8 reads, use the graph of G in the figure to find the following values if they exist. All right, so G of 0. What is G of 0? So at 0, we see that our value is 3. So our answer for that one will be 3. Now, what's the limit as x is approaching 0 of G of x? So for this one, I want to take a look at my graph and look at my whole picture. My whole picture, where is it going to? What is it approaching? So if you look at your picture, we see that it's approaching at 0. Even though it's a hole, it's approaching 2, right? This point right here of 0, 2. So therefore, our limit at G of 0 is 2. Now it's asking, what's G of 1? Let me erase all my other markings. So at 1, there's no problem. We can easily evaluate. G of 1 is 3. And the limit as x is approaching 1 of G of x, well, we see that our whole picture is approaching that same point. So my answer is also 3. Any questions there? Oh, okay, I see something in the chat box. Can you go back to the previous problem? So this problem right here? There you go. All right, you got your screenshot? Okie dokie. So let's go to 10. Oh, the sine 2 pi problem. All right, here we go. So I said that that negative is just direction. So instead of going, when we work with the unit circle, we go counterclockwise, right? We go this way. Since we have a negative, we're gonna go this way. Yeah. So if we're working with degrees, 120 plus 360 to make it positive. Negative 120 plus 360 will get us at, I can't type in, at 240. Did I do that one wrong? Where's my unit circle? Oh, I looked at 3 pi over 2. Never mind. Thank you so much. So your key has an error. I read it as 3 pi over 2. Thank you. All right, so 2 pi over 3 is 1 quadrant and then 1 dot, right? So we're going 1 quadrant and then 30 degrees. So that gives us that negative 2 pi over 3. Thank you so much. And yeah, so if you don't like radians, radians isn't my favorite, but we work with it. So 2 pi over 3 is 120, but negative is just direction. So negative 2 pi over 3 is negative 120. And when you work with it, you want between a positive 0 to 360. So you just add 360 and it gets you to 240. So then you can say what sign at 240? It's negative square root of 3 over 2. This point right here is negative 1/2, negative square root of 3 over 2. Sign is your y. So my answer is negative square root of 3 over 2. Thank you so much. I totally had like a dyslexic moment. Someone asked if it doesn't matter if it's radians or degrees. I would say yes or no. When I work with problems, I personally prefer degrees, so I'll make the effort to change it to degrees. And then if the answer wants in a radians, once I'm done with my problem, I'll switch it back to radians. So it depends if there is a specific saying if it wants radians or degrees. Also, it's like an unwritten rule that whatever you start with, that's what you want as an answer. So if your question's in radians, they want a radian answer, even if it's not said. Another question says, it matters for a calculator, but mostly it matters, oh yeah, exactly. So when you're working with them, if you're punching into your calculator, make sure you're working with degrees or radians. And it's the buttons you're pushing. Thank you so much for bringing up that problem. All right, number 10. Find the following limit or state that it does not exist. All right, so this limit at 0, our problem is that if I just blankly plug in 0, it creates an undefined situation. And that's where we have to be clever and try to work it out. Okay, if it doesn't work out straight off the bat, try factoring. Let's see where that gets us. So to factor, we first have to expand that parentheses of 16 plus h squared. So let's go ahead and expand that. So if I multiply that out, that gives us 16 times 16 is 256. So I have 256 plus 2 times 16 times h, 32h plus h squared. And then we have that minus 256. So my numerator ends up being just 32h plus h squared. H squared plus 32h. And with my denominator of h, we see that I can factor out an h. So then I'm left with h plus 32. and my h's can then divide to make 1. So then I can apply the limit to that. The limit as x is approaching 0 of h plus 32, well, that's h. As h is approaching 0, well, we just substitute that 0 in. So I have 0 plus 32, we get 32. All right. Number 11. Determine the following limits using infinity or negative infinity when appropriate. So I want to look at the limit as x is approaching 6 from the right, 4 over x minus 6. The limit as x is approaching 6 from the left, of 4 over x minus 6. And the limit as x approaching 6 of 4 over x minus 6. Okay, so let's take a look at each one separately. Oh, hold on. My cat got loose. All right. So let's do each one separately. Let's do that first one. So I have the limit as x is approaching 6 to the right of 4 over x minus 6. So for this problem, we see we can't factor, and we're trying to apply the limit from one direction. Okay, so if x is coming from the right, I always think of a number line. If it's coming from the right, think of a number that would be slightly bigger to give you an idea of what's happening. So whatever slightly number you would want. So like, let's say 6.1. If I have that 6.1 minus 6, my denominator would be positive. And the numerator would just be 4. So that stays as a positive 4. So my answer would be positive over positive. And because I can't simplify, and also we know that x minus 6 in the bottom of this rational function is creating an asymptote. So at the asymptote, I know it's going to go either up to infinity or it's going to go down to infinity. So it's just us to determine if it's positive or negative infinity. Because we have a positive divided by a positive, it's positive infinity. Let's do the next one.
I apologize for the interruption, but there are people asking for the first question that we went to. They're asking in the chat about domain and ranges.
Okay, I'll go back to at the very end.
Okay.
Yeah. All right. So I have the limit as x approaching negative 6 of 4 over x minus 6. So same idea. So I always think of a number line and I think what number is slightly less than. So if we think of what we're seeing and what the function is, it's a rational function with asymptote at 6. So we're trying to see what's happening at 6 from the left. So think of the smallest number you can think of that's to the left of 6. You can think of 5.99, for example. And you see that if you think of that smaller number than 6, when you subtract 6 from the denominator, you'll get a negative. And no matter what number to the left of 6 you choose, it will always get a negative when you subtract 6. In the numerator, we still have that positive 4. So at the asymptote, our graph is going to, well, a positive divided by a negative, that'll give us negative infinity. All right, so now we're asked to think about, well, what's going on at 6? The limit as x approaching 6 of 4 over x minus 6. Well, we see that our limit from the left and our limit from the right are not the same. So since they're not the same, we would say the limit does not exist. All right. Any questions about 11?
Wouldn't it be possible to determine the limit if you did like 6.1 and 5.9? I thought that was something we learned.
Yeah. Isn't that what I said?
Oh, I thought you wrote that the limit doesn't exist.
Oh, yeah, I'm sorry, the limit for our function. So the limit from the right. So we have a rational function, and we have an asymptote at 6. And I don't know what's going on really, but we know that if it's coming from the right, we said we're going to positive infinity, so it's going this way. If we're coming from the left, according to our calculations, it's going to negative infinity. So because these points are going different directions, our final conclusion, limit as x approaching 6, we say doesn't exist.
Okay.
Did that make better sense? Or do you still have a
so.
question?
I think it makes sense.
Okay. You don't convince me.
I'm not able to convince a lot of people of a lot of things.
Okay. Well, if it ever comes back to haunt you, like, wait, why is that so? You can always email me, all right?
All right.
All right. Next question. Evaluate the limit as x is approaching infinity of 8 over 8, I read that wrong, 8 plus 11 over x squared. So you want to think of what your question is asking, first of all. So if it's telling us what is x is x approaching infinity, well, it's telling us, well, what is all these x's like coming to? What's happening, right? Okay, well, the way we approach this problem is we go ahead, since we have these two terms, we can apply the limit to each one of these terms separately. Now, our trick to dealing with limits to infinity is this idea of a fraction. If I pick a bigger and bigger number in our denominator, it will make it so I get a smaller and smaller and smaller and smaller number approaching 0. So we use this trick that the limit as x approaching infinity of a fraction with our denominator being an x of a higher degree, we say it's approaching 0. All right, so let's go ahead and take the limit of this one. So I have the limit as x is approaching infinity of 8, and the limit as x is approaching infinity of 11 over x squared. All right, well, we have a constant for that first one. And a constant is a constant, so that stays at 8. Now for our second term, because we have that fraction with the variable being larger at the denominator, as our x gets bigger, this ends up being 0. So I always draw a little arrow and a 0, so I know that it's approaching 0. So we're left with 8 plus 0, which gives us 8. All right, let's take a look at 14. Fourteen says, determine the limit x minus infinity, the limit as x is approaching infinity of 10x cubed plus 4x squared minus 2x divided by 15x cubed plus x squared plus 2x plus 3. So this one, there's different ways to think about it. So one of them is the concept. What are we doing? What's happening? We have a rational function, and we see that we have a horizontal asymptote. We have a horizontal asymptote because we have the numerator and the denominator of equal degree. We see they're both degree 3. And if you recall, their leading coefficients create a horizontal asymptote. So our graph, as x keeps getting bigger, is getting closer and closer to the asymptote. So you can think about it that way. Or we can use our trick, that same idea of applying that fraction of dividing, or that fraction of the idea of a fraction equaling 0. Now to do this one, we go ahead and we divide by the largest degree of your denominator. So we see our denominator, the biggest degree we have is that x cubed. So we're going to divide everything by x cubed. We have 10x cubed divided by x cubed plus 4x squared divided by x cubed minus 2x divided by x cubed and divided by x cubed plus x squared divided by x cubed plus 2x divided by x cubed plus 3 divided by x cubed. Now, like we did in the last problem, if my denominator has an x of larger degree than the numerator, then that fraction, as my x's get bigger, will approach 0. So for my first term, well, those make 1, they're gone. For my second term, they're approaching 0. For my second term, they're approaching 0. So think of those as zeros. In my denominator, that first term will give us 15. That second term will approach 0. That third term will approach 0. And that fourth term will approach 0. So that we're left with just 10 over 15. So our limit as x approaching infinity is that reduced. So it would be 2 over 3. That is our limit.
How do you know that those approach 0?
You know they approach 0 because we're taking the idea of the limit as x approaching infinity of 1 over x. So if you think of what this means, it says x is approaching infinity. So x is getting exponentially larger. So if I pick an x of, well, not 0, of 1, 500, 1,000, 10,000, we see that we get smaller and smaller and smaller and smaller numbers. So the first one we get 1 over 10, so it's 0.1. Ooh, 1 over 500. Gives us 0.002. 1 over 1,000 gives us 0.001. And 1 over 1, 2, 3, 4, 5 gives us point. So these numbers get smaller and smaller and smaller to the point where they're getting closer and closer and closer, but never actually 0. So we apply this idea that if I have a fraction where my x in my denominator is bigger, then if it's approaching infinity, this fraction is getting closer and closer and closer to 0. So with that trick in mind, we apply that to each term when I am taking the limit to infinity. I don't know if I made it overly weird or complicated. Did that answer your question?
Yeah, it did. Thank you.
No problemo. All right. And the other ones, I left them to you, they're not so bad. Remember, so let's take a look at 15. I won't do it. You can do that one. But the limit is what our graph is approaching. So if I can straight off the bat evaluate and just substitute that value in, that is my limit. So for 15, There's no like hot trick to try out. You just plug it in. You can do 15. All right, so that question about number 2. Number 2 is a weird one. I'll give you that. So number 2, when I was working out this problem and I graphed it on Desmos, it gives you a line. So yeah, you're right, it's a linear function. But then when I went ahead and I worked it out and tried to give you an answer for the exam, it doesn't give you all real numbers. All right, so I was like, what's going on here? And then I thought, well, what is a range? A range is the corresponding outcome of your domain. And then I was like, okay, well, if I simplify it and I see what that outcome is at 4, then that should produce a problem also in our range. So that is why we simplified and plugged in that 4 to give us that corresponding range to that domain. But yes, Adrian, in your comment, you're like, hey, it's linear. Shouldn't it be real numbers? Yeah, I think I thought the same thing. But then when I went through this problem, it wanted this as an answer. So I'm thinking if we're looking at what a domain and a range is, this is what it is referring to. Did that answer your concern, Adrian? Cool. But yes, you're right. You're like, hey, it's a line. Shouldn't it be linear? I agree. Okay, so this was your brief little review. Now, let me show you something before we take off. So no, I know I'll do. So I'm going to share my screen. Because I want to make sure we're all on the same page. So I always change up your homepage. I'm sure you caught on to that. And I kind of tell we're going to go over. In modules, you have everything. So what I want to show you is that on the very top of the modules, oh man, it's not there. On the very top of the modules, I'm going to add, I guess I haven't, I will add a unit circle and a cheat sheet of identities. I also want to show you office hours. So I don't know if you caught my announcement. I offer office hours every Tuesday and Thursday from 1 to 2, and Mondays and Wednesdays from 5:30 to 7. And you just click that link and enter the password and it's there. So if you have questions, stop by. I'll be here Zooming. I also want to show you that this recording, if weren't able to come, that's fine. We're all adults, we're all busy. You can find that this recording on that page where you have the Zoom information. So you'll see here that I said I'll post the recording as it's available. So it takes like about half an hour for Zoom to let me know that the recording is available. And then depending on my internet on that day or at this moment, I will upload it onto YouTube and then post it there. Once it's available, I'll send an announcement letting you know the recording is available. Also, our document for today is at that same page. I have it as Word and a PDF and also a key. So you can see every step there of what we did today. Every problem's worked out. Now, I have 2 classes of multivariable. One is, I think we meet at Monday, Wednesdays at 8. The other one's Tuesday, Thursdays at 6. But I gave you all that same Zoom meeting today. I didn't think it was, I don't know, worth to have 2 Zoom meetings. I mentally like the idea of having a Zoom meeting after every chapter, but if you feel like we need to meet more often, you can send me an email and I can say, hey, someone says we should meet more, let's take a survey to have a meeting. And we can go ahead and do that. It's not that I want to see you, I would like to see you more, But I know that online learning is different. We're at home all day, and I want you to study the time that works best for you. Know that I'm here for you. I want you to do well. So that's that. I do see the chat blowing up. Where can you find your tests? So your tests will be available at 7. You can always find everything on My Lab and Mastering. So actually, it should be there soon. And then after a minute, after it's linked up, then I'll add it to the week. So for this week, I will add it after our meeting. It's not showing up for me yet. So at 7, I'll add it to your module, but you can always find all your assignments here at My Lab and Mastering and access everything there. Does the test include 2.6 or does it stop at 2.5? It includes 2.6. So you don't have to take the test today. I only need to take the test by October 1st. Exactly. You can take the test whenever works best for you. Like I said, I don't know what's going on in your other classes. I don't know if you have something that's due tonight and they have to take a test tonight too. So I always like to give you a window of a week to complete assignments. Yeah, and so someone answered the question. All right, I'm going to go ahead and stop the recording.